Welcome back to the classroom. My name is Mr. Wong. Today we'll be covering the 1995 HSC Physics paper. This is to cover Module 5, Inquiry Question 2, Circular Motion. This is question 18, worth 6 marks. Now you might have seen me upload this video before. I'm just redoing this one again because there was a slight error in one of the questions, so I'll rectify my mistakes here. So we have a ball of mass m hangs from a string and moves with a constant speed, and it makes a string angle of 30 degrees with the vertical, like so. So draw a vector diagram of the forces acting on the ball. There are, and I'm going to do it in this part up here, we have the tension force, we have the gravitational weight force, and we have our net force that is driving this circular motion, our centripetal force. We also talked about before what exactly is the centripetal force in this diagram, and that is the horizontal component of our tension force. So when I draw my tension force like this, 30 degrees tension force, there is a vertical component, Ty, and there is a horizontal component to it, X. Okay? The vertical component is cancelling out the gravitational force, hence why it's able to spin horizontally exactly. And so the remaining unbalanced force is our tension force in the horizontal direction, and that is the origin of our centripetal force. So there's that. Okay, question B says, what is the acceleration of the ball? Okay, so to do this question, as you can see, we are dealing with a mass m. So we don't know what the mass is. We have angle, so we want to find acceleration. Now the acceleration is this component here, right? The motion going inward. So let's try and see if we can come up with something that is that can be used. So the formula for centripetal force is mv squared over r. So that's probably not possible. We don't know radius, we don't know velocity. But if we look at the formula for force is ma, and the expression for gravitational force is mg. Now, we can do something. So we're going to use the tan theta relationship. We're going to use the opposite side and the adjacent side to come up with a little relationship. So we're going to use tan theta equals to, the opposite side was our net force, and our our adjacent side is our hypotenuse, or adjacent side, sorry. So tan 30 equals to, let's break it out, m times ac, that's our centripetal force, or centripetal acceleration, and then m times g, acceleration due to gravity. Okay, so now what we can see here from this expression, these two m's will cancel each other out, and we're left with tan 30. We can move g over, because g is 9.8. Okay, so in which case 9.8 AC. So let's put that into our calculator and see what we can get. Whoops, tan 30 times 9.8, sorry. And so we get a value of approximately, to 3 sig figs, about 5.66 meters per second squared to center, because that's a centripetal force. Excellent. All right, last one is, says Write an equation for the tension in the string under these conditions. So we want to find Ft. All right, so we know we can express it as a equation or formula using our gravitational force and our net force or our centripetal force. Okay, so we could express it if we're going by, I'll draw the triangle out again. Net force, Fg, whoops, should be going down that way, and then theta. So we could use the gravitational force. So that would be cos theta. So it would be cos theta equals to, let's see, Fg over Ft. And then by expressing that, it would be Ft equals to Fg cos theta. Okay, let's just make sure I got this one right. Yep. So the tension force is expressed as 9.8 m, being because gravitational force, as we showed above, is mg, and g is 9.8. Okay, and cos theta would be cos 30 degrees, because that's what we had originally there. So you can express this equation. If we knew mass, we would be able to then find the value for the tension force. And that's how you do the question for this one here. It is from the 1995 paper, so it's a long time ago. But if you found videos like these explaining exam questions really helpful, give this a like, subscribe, and I'll